Hello everyone, how are you? Today we are going to see about basics of Visual Basic for Application, that is VBA. In this video we are going to learn first of all how computer works, how programming chronologically developed in this era. So first of all we are going to learn about the basic of computing. Then only you will understand that most of the language, not only VBA programming language, most of the languages follow the same method of computing the data. But there may be some slight difference in the way of how they work. But overall, if we know how computer works from the basics, then it will be easy for us to learn any programming languages. So first we are going to see about the basics. Then we are going to learn about VBA. Let's begin. Everything began from the invention of this so-called device, vacuum tube. I'm not going to tell you who found this device, when this invention was made, and I'm not going to talk about the facts of this device, but I'm going to tell you how this device works. First, you just observe the animation. I think you are observing it. So, when there is a positive voltage in the wire, this wire, then there is a flow of electrons from cathode to anode. Because of the flow of electron from cathode to anode, the circuit is completed. Hence, the bulb glows. If there is no voltage, now it is positive, so the circuit is completed. Now when there is no voltage or negative, then the electron flow is restricted. Thus, the bulb doesn't glow. I believe you understand this. When there is a positive voltage, the electron flows, the bulb glows. When there is negative, it is restricted, so this circuit is broken and the bulb doesn't glow. So positive, negative, isn't it? I believe you understand. This old device acts as a switch where on and off is controlled by that incoming voltage. So this voltage controls the on and off. But how this concept is going to help us in programming or computing? Let us see in the upcoming slides. Now, you have to remember that when we give positive, that is 1, we are going to get 1 as an output. When we give 0 as an input, then we are going to get 0 as an output. Now, let's see the simplified version of the device which changed this world. So we have a simplified version of this device. This is a vacuum tube. We have a simplified version of that device which changed the world. The device is called transistor. The working principle of transistor is same as the vacuum tube, but the difference is the size of the device and the voltage it intakes to work. The voltage this transistor intakes to work is less compared to vacuum tube. If you see this transistor, here we have 3 strands as you see in this image, this is known as emitter and this is known as collector, and the one which controls the circuit is known as base. The concept is same. When there is positive voltage in base, then the electron flows from emitter to collector. When there is no voltage, then depletion layer is formed, which restricts the flow of electron. You see, depletion layer is formed when there is no voltage, then this restricts the flow of electron, thus the circuit is broken. So this is very much similar. When we give a positive voltage, we are going to get electrons flowing, so the circuit is closed, so the bulb is going to glow when we connect this one and this one, so the circuit will be closed. When the electron is restricted, the circuit is not going to be closed, so it is going to be open, so we get 0 as output. So 1, we get 1 as output, for 0 we get 0 as output. The same concept of vacuum tube here, but the way it works differs, that's all. But the principle is same, 0 for 0, 1 for 1. So if you give 0, then we are going to get a complete circuit, so 0. So that's the concept. You have to keep only that in your mind. This is going to act as a switch, which is controlled by this voltage, that's all. Okay, logic gates. So now we saw two things. One is transistor, other one is vacuum tube. Both works same. Both working principles are same, but the method they work is different. Now we see logic gate. If you see here, by connecting the transistor in various form, we can create logic gates. If you see here, transistor is connected in various form. Thus, we get AND gate. And if you connect transistor in this way, we get OR gate. Likewise, we can get these much logic gates by connecting transistor in different way. By using these logic gates, we use transistor to create logic gates, and using logic gates, we are going to create a circuit that can perform arithmetic operations like addition, subtraction, multiplication, whatever we do in mathematics, and also other logical operation as well as. So this logic gates is the basic for creating a circuit, and transistor is very much important to make these logic gates. So if you see here, everything started from a very small little thing that is controlling, that is a switch controlling the flow of electron using the voltage. We are going to create a circuit that is going to do arithmetic operation. You see how beautiful it is, just converting something simple into a very complex thing. Then we are using that thing to solve again the simpler one. Okay, jokes apart. By advancement in these logic gates, what happened? Circuits, by using these logic gates and creating circuits, the main hero got entered, that is central processing unit was formed, which led to modern computer that we use today. From this slide, only thing you have to remember is we give input in the form of coding or machine language or whatever you know, which is processed here in the CPU. Finally, we get output. The input can be given by coding or using any programming languages or any user interface. Internally, it runs, okay? Don't worry about those things. The CPU is going to, using logic gates and circuits, it is going to process it and it is going to give us output. So this is the basic logic of computing. So this CPU entered this world, which changed everything, isn't it? Every computer that we use today has CPU, central processing unit, which processes data and gives us output. Even the mobile phone you use today has central processing unit, which processes data and helps to display you the video, isn't it? So using this CPU, the computing has become so simple. But how we can instruct a computer? What is programming? Isn't it? What is programming? Programming is a way to instruct, isn't it? In layman term, we can define programming is a way to instruct the computer to perform various tasks. That is, computer does not have any intelligence. Whatever we instruct, it is going to execute it without any hesitation. But there is a problem, isn't it? We are going to give input, that is, we are going to give input to the computer, that is CPU or computer, whatever you say, and we are going to get output. But this input, what we give as an instruction to the computer, is known as programming. But how we can instruct a computer? How we can instruct? To instruct a computer, we need a language that computer can understand. So we humans gave meaning to zeros and ones, isn't it? At the beginning of the slide, what we saw, if you don't remember, you just go to the beginning of the video. What we saw, we just gave 1 and 0 as input to transistor. It is going to give the same 1 and 0 as output. So using the input voltage, we are going to get an output voltage, isn't it? Output 1 or 0, the bulb glows when there is one input, that is when there is positive voltage in the input. When there is no voltage, then the bulb is not going to glow. So we are going to give it in only 2, that is binary, isn't it? This is what we call binary. So computer only knows binary. But humans, we speak many languages, isn't it? So we have to give a meaning. We need a language that computer can understand. So computer understands only 0 and 1. So what we did is we just gave meaning to 0 and 1. Like you see here, we have given 0 and 1. We just gave meaning. We are just making the computer to understand what is 1, what is 1 0, what is 1 1, isn't it? But we successfully made computer to understand 0 and 1. But this is not easy for human being. This language is not easy for human being, isn't it? This may be easy for computer, but these zeros and ones are not easy for human being. We cannot keep on typing 0, 1, 0, 0, 1, 0 like that. Then to type A itself, we have to give 1, 2, 3, 4, 5, 6 input, isn't it? For 8-bit computer, we have to give 8-bit. So the task is going to become harder. So what we need actually, we just formed a computer language. Okay, we made a language that computer can understand, but it is difficult for us. So what we exactly need? We need a language that is closer to human as well as computer should understand. Such a language is known as programming language. Do you understand? So we need a language that human as well as computer both should understand. Such a language is programming language. However, a programming language need to be closer to human language, isn't it? Then only we can easily program anything. But if programming language is closer to human language, then it will be difficult for computer or impossible for computer to understand, isn't it? If it is closer to us, then computer has difficulty in understanding. So we need a machine or engine that translates human language to computer language, isn't it? We need an engine or translator. Like how we translate, if I know English, if others speak Spanish or Hindi, so to make him understand, I need a translator who knows both the language, isn't it? We need a translator, or we use Google Translator, isn't it? We just speak in English, the Google Translator translate it in the language that we need, for example, Hindi or Spanish. So it gives us the output, isn't it? So we need a translator. Such a translator was finally found, and it is known as compiler. So compiler is nothing but a translator or a machine that converts human language to computer language, machine language, basically. And this compiler engine was found by, or was first used by FORTRAN, formula translating system. This is a programming language that used this compiler engine to convert the human language, that is the programming language that is closer to human to the machine language, isn't it? So this FORTRAN programming language used compiler to convert what we type into the machine language, and again the output was given in the language that we know. So finally we got a solution. We got a translator. We started using a translator to make the communication better. In this world, communication is more important, isn't it? Day to day we communicate to each other. We understand each other because we communicate. We learn anything because of communication, isn't it? So the computer will understand only when we are able to communicate to it. So it is made possible by this compiler machine. So what this FORTRAN simply does? FORTRAN simply gets input from us and compiles it into machine language. Then the computer processes and returns the result. Again, this compiler engine displays the output in respective manner. So here we see a compiler engine. Then there is another such engine known as interpreter. So this is an engine which was used by many programming languages like the FORTRAN. Compiler is an engine. For example, compiler is a way. It's a translating way. It was used by many programming languages. If you see here, interpreter, it is another machine. It is a translating machine, but it works in a different way, which translates line by line of coding into machine language. If you see compiler, it translates this whole program that what we human type at a time into computer language. But this interpreter executes this line by line. It translates line by line of program into computer language. So there is a difference between these two engines, but we use it. For example, if you type everything in Google and give translate, it will give you a result that is different from the line by line or word by word of input that we give to the Google translator. So the result will be different. So many of the programming language use compiler method and many use interpreter. For example, Python language use this method, line by line of translating into computer language. But the FORTRAN, C, C++ use this kind of method of translating the program into computer language. So this is just a translator. It translates the program that we write. We human write this side. So it translates to computer language this side. This is also doing the same thing, interpreter. What it converts, this is the program that we write, and it converts it into computer language, but line by line. That's it. That's the difference. So this is the two engine. These are the two engines. There are two type of translators that are in today's world that converts programming language into computer language. So here we have list of programming language. In 1949, assembly language was created, and in 1949 Shortcode was created, then 52 Autocode was created, and finally the one which was closer to human language, FORTRAN. This programming languages was created in 1957, which used compiler 2. Then in 1955 ALGOL, LISP, COBOL, BASIC, PASCAL, Smalltalk, C, SQL, ADA. You see how exponentially the growth became. If you see here, once someone found a method to convert a method to communicate to the computer, these many languages started to develop. So Pascal, Smalltalk, SQL, ADA, C++, Objective-C, Perl, Haskell, Python, Visual Basic. That is the one we are going to learn today. Java, PHP, JavaScript, C#, Shift. So these many languages came into the world because of that one engine, that one idea to translate human language into computer language. The first question that arises in my mind is why do we need these many languages? We have these many languages, but why do we need it? Isn't it? Why one language cannot satisfy everything? We found FORTRAN, why it cannot satisfy everything? Why we need these many languages? The first acceptable answer to this question is 1. To make the programming language closer to human language, isn't it? When we make a programming language closer to human language, many people can use that programming language to create programs so that they can increase productivity. So increase in productivity reduces consumption of resource. So the losses are reduced and growth will be there, isn't it? So if many people learn to program, then more innovation will come to this world. More thing can happen. The growth can be rapid, isn't it? That's what today we are getting into this rapid kind of growth. If you see, before 1950, the growths are very small. Only the bigger organization or only those who can get investment are able to earn or are able to make something. But today, after the invention of these computer and programming language, nowadays what happened is we have grown. The development what we had previously, it has been raised like anything in the past 50 years. This is only because of this computing, that is programming language or computing or the invention of computer, whatever I say. The growth is only because of these things. We are able to create many things using computer. We are able to calculate many things using computer. Otherwise, it could not have been possible even in doing it in hand. It would have taken many time. So, to make the programming language closer to the human language is the main goal for the presence of these many languages. If you see, the languages have something in them so that it can be closer to the human. And there is another such reason, isn't it? The second reason is to fulfill the purpose. Suppose, just take the language that we speak daily. English is a language that is widely spoken by people across the world. As well as here in India, English is one of the official language. And also, the product that we use today, like keyboard, contain English alphabets and other products also. So this implies how English language is important or has created an impact in our day-to-day life, isn't it? But although English having such an advantage, how it would be when our Prime Minister use English language instead of Hindi in his election campaign? Do you think speaking in English will get him votes? Definitely not. English may be international language, English may be official language, English may be important, but to satisfy the purpose, to fulfill the purpose of getting votes from people of locals, English is not the right choice. We have to speak in the Hindi or the language that is locally spoken. So, similarly, here in programming languages, one programming language cannot fulfill the purpose of various applications. Thus, we have following programming languages where HTML, CSS are used for creating or designing websites. Python is used for creating machine learning programs. SQL is used for data management, and VBA is used for automation and for creating macros. And if you see here, even these languages have its purpose. It will have any purpose. It will fulfill any purpose. It will have at least a purpose to fulfill, isn't it? That's why these languages had been created by human beings. Okay. So, now we are going to get into programming. Whatever we see still now is just the basic, how the programming got into world, why we have these many programming languages, why we use VBA for creating automation programs, why we use VBA for creating macros, isn't it? These are just the basic. Now we are going to see about the main, that is the main content of this video, programming.